In this video, I'm going to show you how you can integrate this in two ways. Both of them will lead to the same answer. So let's say you're integrating within this region. So looking at this, if you make this to be u, then u becomes a constant. Then u equals 1 would be this line. And then if you make this to be u, then u equals 4. So that's this line. So that line gets transformed to this. And then looking at this line, if you make this to be v, then this line here will become v equals 4. So v equals 4, it would then become this line. And then this line here would be v equals 1. So it becomes nice and easy. So this region here will become this region here. And then don't forget, this thing here is v. So we can put v into here. So this whole thing here will then become this. This bit here will become v. And then you're integrating from, in terms of u, you're integrating from 0 to 4. 0 to 4. From 1 to 4. From 1 to 4. From 1 to 4. And then you're scanning from 1 to 4 in the v direction. 1 to 4. But then don't forget, once you've made this transformation, you need to make some sort of adjustment. You need to insert your Jacobian in here. So when you get to this stage here, you now have two choices. You either work all in terms of y and x, or you can work all in terms of u and v. So if you work all in terms of x and y, then when you compute your Jacobian, what you put into here would be the absolute value of your Jacobian. But if you work all in terms of u and v, what you put into your adjustments here would be 1 over the Jacobian. So there's a difference. If you decided to work all in terms of x and y, then simply put your Jacobian into here. If you work all in terms of u and v, then you've got to put 1 over your Jacobian. And right at this moment in time, you don't understand why that's the case. But for the time being, just accept it. When you get to linear algebra and more advanced mathematics, then you will understand why you need to do this. But let me just give you a rough explanation. Let's say you've got this region here. You apply some sort of transformation, and then it becomes 4 times larger. So if you go one way, then you simply times 4. But then if you decide to go backwards, then you times by the reciprocal of this thing here, of 4. That's why you need the 1 over this thing here. So for the time being, you don't fully understand exactly why it works. Just accept it for the time being. If you want to fully understand it, then you need to do some more advanced mathematics. Okay, so let's start again. So if you decided to work all in terms of x and y, then compute your Jacobian. So computing our Jacobian, looking at this, differentiate x with respect to u. So looking at this, if you differentiate this with respect to u, it will then become this. If you differentiate x with respect to v, then this thing here will then become this. And then differentiate y with respect to u, it will then become this. And this will then become this. So now looking at the second method. So the second method says differentiate the u with respect to x. Differentiate the u with respect to x. So that's simply y. And then differentiate u with respect to y, then it will just be x. And then differentiate this, it will then become this. Differentiate this, it will then become this. So now that will then take us to here. So the Jacobian for this would be this times this, that's this thing here, take away this times this, that's this thing here. Looking at the second method, it would be this times this, so that's this thing, take away this times this, that would then be this thing. simplify this, it becomes this. Looking at the first method, simplify these two, it will then become this. So the point here is that you've just computed your Jacobian for both methods. So now for this one, you simply put the absolute value of the Jacobian. But then for this one, you put the absolute value of your Jacobian. So you put the 1 over the absolute value. So that will then become this thing here. And then here you simply put the Jacobian into here. So this thing you put it straight in here. For this one here, you've got to put 1 over that thing. So it becomes this. Don't forget this is v here. Okay, from above. That's v here. Remember we said v equals x times y squared. So going down here, x, you've got x times y squared. So this is v here. This is v. So you can see that they're exactly the same. So you can use. So the point here is that you can work all in terms of u and v, or you can work all in terms of x and y. Both would lead you to the same answer. So we are currently here and here. So they're both the same. So that would then take you to here, and then you can see that this is simply the area of this region, which is 9. So your overall answer would be 9. Okay, so this is your final answer.